Let's sum what we've done. Aaliyah's parents gave us two scenarios for saving money for college. We used a spreadsheet to calculate that implementing both would be a staggering 252% better than Plan L alone. We made a chart to portray that. Then we went back to school and crafting functions for Plan L and Plan E. Of the many lessons to be learned, allow me to stress that, first, we could solve the problem with free software, some basic training, and ingenuity with what we already knew. A level 3 math gunner like me can, with a spreadsheet, seem like a level 6 sniper. Second, charting data is only going to increase as the century progresses. You can get by with spreadsheet software, sure. However, those competing for your paycheck are likely going to know that functions are the shorthand way of expressing a plot on a graph. I repeat for emphasis, functions are the recipe for charting, plotting, graphing, whatever you call it. They are the recipe, so we gots to get familiar with working them. If not for you, then learn it so you can help your kids suffer less through it. Lastly, and most importantly, don't be afraid, and do not be embarrassed. You don't have to know it like you know your times tables. It used to be that you took some courses at a brick-and-mortar school, got a diploma, then had that intelligence in some dusty bin of your brain for when you needed it. In short, you mastered it so that you couldn't forget it. However, the internet has made that kind of knowing not necessary. You don't need to know every step, every rule. Now you just got to know that it's out there and how to web quest some help. Listen, all this messing around we did with the spreadsheet was to convince you that it isn't beyond your ability. You don't need to be a math major to figure it out, not if you stuck with me this far. You just need some more practice, enough practice so that when you do forget it, because you will, you'll be wise enough to know how to inquire for the assistance you need. For some people that means lots of exercise. For others it just means remember how to look up the formula. The only person who can tell you how much practice you need is you. As a tutor, of course, I'd recommend more practice than less. The point is to practice enough so that you can figure out how to archive the essentials in your mind. That's probably a minimum of 3 consecutive questions answered correctly once a week for several weeks. Just saying. So that when the task comes up 3 years later, you're not afraid to take it on. You might need a weekend of research, but you're not intimidated. Okay, I'm stepping off this soapbox. Please give me a little more patience. We should respond to some correspondence before we get to the compound interest formula. GED or Bust writes, how do I figure out when Plan L will equal Plan E? Good question, because it's a common one. With our data, it's not feasible. Look at our data. There isn't ever an occurrence when the values are equal. We're not allowed to granulate to something less than a year, like year 3.67, because the scenario compounds annually. It only happens at the end of each fiscal year. Most textbooks will reword the question to, when will Plan L surpass Plan E? With a small data set like this, you can manually compare, as we did before. Plan B exceeds in year 2, and Plan L, it outpaces in year 4. With larger data sets, consider using a simple coding trick, an if statement. I'm going to use this column to flag when Plan L is greater than Plan E. So I'm going to give the column a label so I know what's going on in the column, and I'm going to use the command if. It's a built-in command in most spreadsheet software. If this number is greater than this number, then, comma, then computer, I want you to display this text, L is greater than E. And I'm going to put close parentheses to tell the computer I'm done with that command. I hit enter and returns false because C2 is not greater than B2. But it's analyzing that row. I can use the fill down command, the beauty of a spreadsheet, to analyze every single row. And so in year 4, L is outpacing E. That brings us to our next question. HSC Teacher 007 asked if I'll demonstrate that Plan E will eventually exceed Plan L. Yes, of course. The point of that question is that we know that when interest compounds, it's growing exponentially. If it continues, it will at some point outpace the linear Plan L. Let's find out what year that will be. Therefore, we must continue the scenarios past year 18. I've taken these scenarios and I'm filling it down to, let's say, year 50. I just copied and filled down. We wrote an if statement here when L was more than E. Let's switch it around for when E is greater than L. So I'll use a different column. In fact, let me delete this column so we don't get confused. When E is greater than L. So that's what I'm going to type in. Equals if when E is greater than L. Then, computer, I want you to display the text E is greater than L. Okay, in the first year, that's true. Look, E is greater than L. So now I'm going to fill down all the way to year 50. Okay, and so it stops at year 4. It stops as predicted. E is not greater than L. And for a while, L is in the lead, and then E takes over in year 37. In year 37, E is greater than L. Let's have a look in the graphing software GeoGebra. So we've got L in orange, E in purple, L, E. We'll have to zoom out past year 18, so I'll flash forward. There. I've zoomed out enough to see the second instance where our exponential path crosses our linear path. It's somewhere between years 36 and 38 as our spreadsheet predicted or calculated. It's with this tool, GeoGebra, that we may answer the original question. When does function E equal, emphasize equal, function L? Because as functions, they can granulate smaller than annually. As functions, they are capable of calculating every instance along the x-axis, every moment in time. Where on the chart does function E equal function L? Can you point to it? Yes, as we've copiously hinted, where they cross each other, which in mathematics is called the intersect. So we want to order up the built-in intersect command. And we've already named our functions L and E, and the software can recognize that. And so there's our first intersection point, a tad before year 4, when the x-coordinate is 3.148 theoretical years. And the y value, the dollar value, will be $1,889. That's when L and E equal each other, the first instance. For the second instance of intersection, we'll enter the intersect command. It's tempting to use this index of intersection point or this initial point. Those don't work because our purple function E isn't a polynomial function. Fortunately, the developers provided another method using the starting and ending x values variation of the command. So I'm going to enter in our functions. We're specifying function E, L and function E. The starting x value can be any value, but we want the second instance, not the first. So we need to pick a value, an x value that happens after the first one. But it also needs to be after our second intersect point. We want the computer to find this between a range of values. So since we know that it's between 36 and 38, I'll specify that. And for some reason, it returns undefined. The computer is struggling to figure out what I'm asking. So I'm going to expand the range of, I'm going to broaden it, and we'll pick 10, and we'll go big, 100. And there's our point B. At 36 and 2/3 theoretical years, function E in purple is equal to function L in orange. At $21,996, function E is equal to function L. Any greater increase in x and function E in purple surpasses function L in orange. With our previous discussion on function E, the compound interest formula isn't so formidable. In broad view, we can see the simple interest formula structure. The principal times the rate times the time, except it's exponent time. The only real complication is n, which represents the number of compoundings. Often it's compounded monthly, although it can be done quarterly, daily. Whatever the term, notice that t is still measured in years. Let's apply the formula to our plan E. I'll use year 3 for demonstration. Here's what we had before. Here's what we do now with the compound interest formula. It's plugging the numbers in the right places, as all formula work amounts to. Careful, mind your order of operations. You have to calculate 1.076 exponent 3 first, to the third power first, before multiplying the 1500. Why did I use 1 for n? Because our plan E at year 3 is an annual interest calculation. It compounds only once in that year 3. So here's our plan E, the entire plan E. See what we only had to do? We only had to change this to 18 years, but everything else stays the same. And I inserted these brackets here to show that we need to do this calculation, this entire calculation first before we multiply the 1500. But other than that, it's a simple plug in the numbers. Let's jump into some practice. See if you can answer these 3 prompts, A, B, and C. Pause the video because I'm going to reveal the answers in 5 seconds. 5, 4, 3, 2, here they come. Am I going to dissect this formula too? Am I going to explain how it works? Nah, that's for another time perhaps. My objective was to introduce you to bridging the gap, to traversing from the land of simple interest to the lands of compound interest. Do not hesitate to use spreadsheets or graphing calculators as tools along the road. The destination is much less important than the journey. What about the function for Plan B? Your enthusiasm is commendable. That function, though, is beyond the scope of this mission. If you look at it carefully, you'll see our work within it. Here's the function here. Use the goodwill of internet for that project. Try searching compound interest formula with annual contributions for starters.